Here is homework help for number 17 on the 60R review homework. So we have a height from a certain distance, the angle of elevation to the top of a building is 17 degrees. Okay, so let's do that. So a certain height from a building. So we have a building here. And from a certain distance, the angle of elevation to the top of the building is 17 degrees. We'll say this is our building here. 17 degrees. At a point 50 meters closer to the building, so 50 meters closer, the angle of elevation is 31 degrees. So note, as you get closer, the angle of elevation is larger, right? So just looking up higher, there definitely is a larger angle. Now we want to find the height of the building. So we could use law of sines here, but we need to find some information first. So we know if this is 31 degrees, we can find the angle here. 180 minus 31 degrees, 180 degrees minus 31 degrees is 149 degrees. So we know this is 149 degrees, that obtuse angle. Then we could figure out this top angle up here. So the interior angles of the triangle is 180, so we can do 180 degrees minus 149 minus 17 degrees. And we'll find that angle is approximately, well, it is 14 degrees. Okay, so 14 degrees. So we know all the angles of the outside triangle here. And so we can use law of sines. And what I want to do is, I know that the building, well, it should be 90 degrees here. And actually, I could find this angle up here. But if I can find this same side here, then I can use right triangle trig, right? So that's one of the options. I'm sure there's lots of ways to solve this problem, but that's the way that I choose to do it. And so let's label this A. Here is B, and I'll label this C. So this is side A, and I'm trying to find side B, which is the side they're sharing for the other triangle I want. So let's use B over sine of B equals A over sine of A. So let's multiply by sine of B, just to simplify it a little bit before I plug in. So find B equals A. A is 50 times sine of angle B. Angle B is 17 degrees over sine of A, which is 140. Sine of A is not 140 degrees. It's 14 degrees here. So then when you plug it in the calculator, you'll find that is 60.43 meters. So 60.43. So I'm really just trying to find the height here. So I have the angle. So I have opposite over hypotenuse. So opposite over hypotenuse, that's sine. So I can use sine of C equals the height over B. So sine of 31 degrees equals the height over about 60.43. So solve for the height. I'm going to multiply by 60.43 to both sides. So I find after I do that, the height is approximately 31.1 meters tall. So we used law of sines, and then we used our right triangle trig as well. So let's look at number 49 from 6.2 as well. So I took out the drawing, so it's good to practice how do you draw it, just as a practice skill. So we have a 100-foot vertical tower that's built on the side of a hill. Okay, vertical tower, meaning it's just straight up and down. And the hill makes a 6-degree angle with the horizontal. So we don't have the figure, we're going to draw it. So here's the hill. Let's say this is 6 degrees. And we have a tower that is vertical, and that is 100 feet. So what we have is a parallel line here. So it's similar, if you already watched the video on the flagpole problem, it's similar to that. And let's see. So 6 degrees, then we want to find the length of each of the two guy wires that are anchored. Okay, so it's anchored 70 75 feet uphill and 75 feet downhill from the base of the tower. Okay, so, you probably would need the picture just so you know what that means. The guy wire is just the wires that are attaching from the top of the building, and it's anchored to the ground. So that's one guy wire, so let's just call that C2. And then that's 75 feet uphill, and then the other way is 75 feet downhill. We'll call that C1, so angle C is here. So I have to figure out those angles. And so that's also 75 feet here. Now we need to figure out some of the angles in here. So we have 6 degrees. We know this is 90. Okay, so remember, so this is parallel lines and alternate interior angles are congruent. So I know that 6 degrees is the angle in here. Vertical angles are congruent, so there's 6 degrees in the angle in here as well. So 6 degrees, 6 degrees. Now what that helps us find is both angles of C here. So remember, to that blue line, that is 90 degrees. Okay, really large, I'll take it out. But 90 degrees, so therefore the left side, the left triangle will be 90 plus 6, and that angle is therefore 96 degrees, right? So the 90 degree plus the 6 degrees. Now on the other side, it's less than 90 degrees, right? Less than 90, and it's less by 6 degrees. So 90 minus 6 degrees is going to be 84 degrees. Okay, so we have side angle side, and so we can use law of cosines for these triangles as well to find the lengths of both of the wires. So we can use, let's see, C1 squared equals, so one side is 75 squared, the other side is 100 feet squared, and then minus 2 times 75 times 100 times cosine of that left triangle of 96 degrees. And then the other side of the wire will be similar, right? The only difference, because the length down here is the same, 75 and 75, and 100 is the same for both of the triangles. The only difference is the 84 degrees here. Okay, so let's write that. So it's going to be still 75 squared plus that 100 squared minus 2 times 75 times 100. And this time it's cosine of 84 degrees. So you'll plug it in your calculator. Make sure you are square rooting it because it is squared. And then you'll find that the first one will be 131.12 feet. And then the other length will be 118.6 feet.